We'd already talked about torque, and today's idea we want to talk about torque when the torques are unbalanced. First, let's talk about the definition of torque, and torque is a twist or a turn. So it's something that's going to cause something to rotate. Force causes something to move in a straight line, a push or a pull, and a torque is a twist or a turn, causes something to rotate. When we talk about unbalanced forces, we say that an unbalanced force, according to the second law, will cause an acceleration. Well, unbalanced torques will do something similar. In this case, an unbalanced torque will cause something to have an acceleration, but it's going to cause an angular acceleration. So again, first law says when all the forces or torques are equal, the object either stays at rest or moves at a constant velocity. When they are unbalanced, it causes an acceleration. Our symbol for torque, as revealed, torque is the Greek letter tau. And the equation, we already had the equation that torque is force times distance times the sine of the angle. But now what we're going to do is look in terms of the second law of motion. The second law of motion says the total force equals mass times acceleration. So here we have the total torque. And if we just kind of look at our progression so far, we talked about displacement, both linear and angular. We talked about velocity, both linear and angular. We talked about acceleration, both linear and angular. And when we talked about force, this rotational analogy would be torque. Instead of a push or pull, we have a twist or a turn. And instead of mass, which is inertia in a straight line, we have moment of inertia. This is an object's resistance to move, and this is an object's resistance to changing its rotational motion. So if we look at that, total force equals mass times acceleration. We're just replacing force with torque, and we're replacing mass with moment of inertia, and we're replacing acceleration with angular acceleration. So this is our second law of motion in terms of rotation. It's really just the second law. Units are still a Newton times a meter. We can see that from the first equation. Force is Newton times distance, which is in meters. It is a vector where counterclockwise is going to be positive. Examples, we're just looking at examples of anything that is being twisted or turned. So maybe we can talk about the opening a jar. Perhaps a wrench, turning a wrench. We can also talk about, our arm, when we rotate our arm. By picking objects up. Those would all be examples of torques where we have to rotate something.